the recording.
Okay.
Okay, recording is started. Then I will make you host again, and you
Yeah,
can.
okay. So unless you
Okay, sir. Now it is okay. You can continue, sir.
দেখুন তো স্ক্রিনটা শেয়ার হলো কিনা
Yes, okay, sir.
Okay.
It is okay. Okay, sir.
So in the last class we discussed the DCOP distributed constraint optimization problem with a small example of sensor network where each sensor we assumed as a variable x1 x2 x3 at a moment a sensor can or that x1 x2 these variables can have values from the domain. Here the domain is the sensor can either view its north side or south side or east side or west side. So depending on that, the domain is north, east, west, south. So x1 can take any of these values at a time. x2 can take any of these value at a time. So that was our objective. Now, initially we modeled it as a constraint satisfaction problem. The constraint is you have to track a particular target. So here you see for x1, x3, x5, if they choose the values south, west, and north, the constraint is satisfied. So that is our objective, to satisfy the constraint. The same problem can be modeled as maximization of the CSE problem. The maximum number of constraint can be satisfied, not a single constraint, rather than maximum number of constraint can be satisfied. The same problem can be modeled as your constraint optimization problem, where for each constraint satisfaction is an associated value like cost. If it is a cost, then the total sum of the cost should be minimized. That is the objective of the problem. So minimize the total cost. Or if it is an utility or some kind of value payoff or profit, then objective will be to maximize the sum of this profit. So far we have discussed COP, CSP, whatever. These are the notion of centralized approach. The centralized approach means that we knows the computation unit knows every information of the whole world. That means the entire scenario is known to the computational unit. But in reality, that is not possible. You can only know it your neighbor. I can sense the environment of Durgapur only. Now I can tell whether it is a rainy or it is a cold weather or hot weather. But I cannot tell the weather of Ramgarh right now. So that's why the notion comes for distributed constraint optimization, where we are putting a single agent who can control each of these sensors. For example, there is a sensor who is controlling the values of x1. There is a sensor there is an agent who is controlling the values of sensor x3, similarly for x5, like this way. So this agent can sense the environment and act upon it. Okay, this agent can interact with its neighbor only. That means direct neighbor. If you go for the graph theory problem, then it will be the adjacent node. Now, the objective of this agent is they are forming a multi-agent. As I said earlier, that they are forming a group of agents who are working together to achieve some common goal, just like the society. You may belong to a family. Maybe in your family there are 5-6 members. There are some objective in the family. The same way, and all the family members are trying to optimize that objective. In the same way, these autonomous agents, number of agents working in a particular environment, they have something in their mind. They have something in their mind as a goal, and all they are executing for achieving that goal. So this was the model, that A1 is responsible for choosing the value of x1, A3 is responsible for choosing the value of x3, A5 is responsible for choosing the value of x5. Here A1, A2, A3, A4, A5 are the agents, and x1, x2, x3 are the variables or the variables value of the sensor. So for example, A1 is the agent who will decide what will be the value of X1, whether it will be north or south or east or west. A3 is the agent who will be responsible for choosing the value of X3, north, south or east or west. And each agent can interact. When we discussed day before yesterday, the multi-agent system, there is a concept of society, agent society. So an agent can interact with its neighbor member or neighboring members, just like the society we have. So that COP problem has been modeled as DCOP, where there is one more line called this agent. The notion of agent come in the picture. Agent set, variable you already are familiar, domain, constraint, everything. So here each agent is responsible for choosing the values of X1. A2 is responsible for choosing the value of X2 like this way. And the goal is find an assignment that minimizes the sum of the cost for all the constraints. Here, as we told that the objective is the cost, so obviously the objective will be to minimize the total cost. Okay. So that was our last class discussion, and based on that we started the algorithms.
Yeah.
Bolo. Hello.
ऐसे नहीं पहनती है.
Latasri, please mute. Latasri, Saurabh,
Are you asking
Ashok.
a question?
No, sir. Actually, she is talking with someone other.
Okay, no problem.
Please.
No problem. So we started the algorithms. First, we categorize the different algorithms which are used for solving the DCOP problem. They are mainly of two types: complete algorithm, incomplete algorithm. Complete algorithm guarantees that this will give you the optimum result. If it is a minimization problem, it will give you the minimum value assignment. If it is a maximization problem, it will give the assignment with the maximum values that return the maximum values. If it is an but mind it, for complete algorithm, if you go for complete algorithm, then you need to reach to the end of the algorithm. In between, you cannot get any result. You have a starting point. You have to execute the complete algorithm. Then only you will get the final result, the maximization result, the minimization. But for incomplete algorithm, you can start in any point. Even if you don't go to the end of the algorithm, just a minute. So if you go for incomplete algorithm, then there is a starting point, and in any moment of time, you can ask for the solution. That solution may not be complete. That solution may not be the optimum solution, but you can get a solution. So that is the difference between a complete algorithm and an incomplete algorithm. The complete algorithm will always return the optimum result, but that will be returned at the end of the algorithm. But for the incomplete algorithm, you can get the result at any moment of time. You can expect result at any moment of time, whenever you require. You don't need to wait for the end of the algorithm. But there is no guarantee that the result will be the optimum result. So that's why it is called anytime algorithm. You are ready, the algorithm is ready to give you a result at any time. You can expect result at any time. There is no guarantee of the solutions. Okay. So based on that, we discussed the synchronous branch and bound algorithm, which is of type complete, fully decentralized. There is, you won't find a single node who is responsible for the entire computation. So complete, fully decentralized, it is synchronous, and it is search based. So we discussed that one, synchronous branch and bound. I'm not going again in the detail of this. So there are some metric that we discussed already, and also I have pointed out one more thing. I think all of you are familiar with the algorithm, because in the BTech level you must have an algorithm as a paper. But normally the course is in BTech syllabus as an algorithm. It is of centralized in nature. That means assume that my entire computation is being taking place in a central node. So there is no concept of network as such. So that's why you don't need to think about the network load, packet size, or message size. We don't need to think about this thing. But when you go for distributed algorithms or distributed approach, then apart from the runtime the network complexity, I mean the network total number of message passing, message size, etc., etc. So that means associated network parameters will also be there. Message passing complexity, size, message size complexity, all these things you need to take care. Okay. Next, I will be going to the next algorithm, DCOP, distributed pseudo-tree optimization procedure, which is inference based. The earlier one was search based, this one as inference based. So before going to the DCOP, first we need to know what is pseudo-tree. For example, take the same graph ABCD. This is the number of arc and the nodes. First you take the spanning tree of it. First you take the spanning tree of this. So if you draw the spanning tree of this graph, it will be looking like A, B, then BC and BD. So this is the spanning tree of the given graph. Then what do you need to do? As there is a connection from C to A, but if you take just the spanning tree, that will not be shown. So you just draw a dotted line. That means there was a connection from A to C in the main tree. So this is called the pseudo-tree. Now, how the DCOP algorithm works. This is the pseudo-tree of the given graph. There are two directions. In one direction, the utilities will go up, and in the other direction, the value will come down. So from the leaf node to the root node, the utility values will be traversing, and from the root node to the leaf node, the values means that which node is choosing which color, that values will be traversing as a message. So utility phase leaves to root, value phase root to leaves. So take this example that this is my tree and this is the pseudo tree of the given tree, and the values, utility values are already given. I think. Yeah. This has already been given. So we are taking the same values, this table. Now you see, if from the end of D, or from the leaf of D, we are trying to compute the utilities of this part, BD. Now, starting from D, the values will be starting from B. So keeping B as red, what will be the possible type of D can be? So if I choose B as red, D can be red or D can be green. So keeping B as red, R and R, D can be red or green. So if B is red and the D is red, the value is given as 3. If the B is red and the D is green, the value is given from the table as 8. Now change the value of value of B, Bombay. Put the value of B as green. And if you put the value of B as green, what are the possible values D can take? D can take either red or green. Keeping the value B as green, D will, if D choose R, that is red, the value will be 10 from the table. And keeping the B as green, if D choose green, then it will be 3. So what we understand from here, if we choose B as a red, then if D choose red, then the value will be minimum 3, because minimum of 3 and 8 is the minimum is 3, and this is possible when this is red and this is green. Other option can be, if B choose green, then out of this 2 value, the minimum is 3, which is obtained when the D is green. So minimum of these 2 is 3, minimum of these 2 is 3. And when it is possible? When B is red and D is red, the minimum is 3. That gives the minimum value. When the B is green, if red choose green, that gives you the minimum value. So we can get the minimum values from these 2 combination as R as red and R as green. At the beginning we told the utilities moves from leaf to root and the values moves from top to bottom. So we are choosing the values of B and calculating the utilities from D. If you want, I can discuss this thing once more. because the main tricks is here.
Yes, sir. One
Sir,
second.
one second, please.
Sir, one
Sure.
second.
Sir, one second.
Sure. I will request all of you, those who are really interested about things, please draw this table. I think Bhaskar, আগের দিন তো আপনারা মনে হয় করেছিলেন এটা। এটা জাস্ট একটু ড্র করে
Already I have taken, sir. Not an issue.
বা মোবাইলে ছবি তুলে রেখে দিন এটা। মানে এটা আমাদের লাগবে। এখান থেকে
Okay, please everyone take a snap.
Of course, if you feel that. মানে সবাইকে বলে দিলে আপনি if you feel that you can take a snap or can then it will be easy for us to traverse back. Okay. Okay. The first idea is the utility moves from leaf to root. Sorry. Utility moves from leaf to root. ওপরের দিকে যাচ্ছে, and the values means which node will take which color, that moves from root to leaf. That is the main concept. And for each of these arc we will be taking individually, and we will be considering that as here we are treating as a cost, so we will choose that particular combination which gives you the minimum cost. That is our objective.
Sir, one thing, util, what is the meaning of util? Basic that utility that
Yeah, I'm telling you. So utility, it can be cost, it can be profit, whatever. If let me tell you, if it is cost, then our objective will be to find out the minimum value. If it is profit, then we have to take the maximum value.
Okay.
Because
okay, that may be maximum, that may be minimum.
Yeah, that may be that may be maximum, that may be minimum, depending on our requirement.
Requirement, okay, sir. Okay.
Because if it is a profit, if it is a profit, then obviously we will try to maximize the profit. But
yes,
if it is
yes,
a cost, then always we will try to minimize the cost.
Yes.
So if it is a profit, then we will take the maximum of it. If it is a cost, then we will be taking the minimum of it. Okay. So for this particular example, we are taking the cost. You can try it with the profit as well.
Okay.
Right. Just instead of choosing the minimum, we have to choose the maximum one. Now, let us first start from any end. You can start from this end also. You can start it from this end also. So first, let us start with this end. Okay. So this is the arc. This is the arc.
Yes, yes.
So put it in something different color. That means we are considering for this iteration, we are considering this arc as our computation. Now I told you that value passes from top to bottom, and utility passes from bottom to up. So we will be, so for this particular arc, the top is B and the leaf is D. So first take the values of D. What will be the values of D? D can choose either red or it can choose green. There is only two options because we are considering only two color. So B can choose either the red color or it can choose the green color. If B choose red color, then what D can do? D can either choose red color or can choose green color. So if now you see my mouse, if I take B as red, D can be red. If I choose B as red, D can be green. So first consider this two line, this two row. For both the cases, B as red, but D can be red or green. As I said, the values are coming from up to down. So we have selected B first, and then we are selecting D. That's why I told you the values moves from top to bottom, utilities moves from bottom to up. So first fix the value of B, then you choose the value of D. As I said, the values moves from bottom to top to bottom. Now, if this is the combination red, then you see the table that you have taken the snap. The value is BD. If B and D both are red, it will give 3. 3 দিচ্ছে.
3, sir. Okay.
3. If B and D, one is red, another is green, the value is
again 8. 8. Yes.
Keep it as it is. Now change the value of B again. Earlier we choose as a red. The next can be green. So if we fix the value of B as green, what can be the possible color of D? D can be red or green?
Yes.
Huh? Yes. Any question? Hello?
Saurabh, any question?
No.
No, sir. Please mute if you have any question.
So, if we choose B as green and D as red, the BD value is 10. That means this art value is giving you the value as 10 from the table. If you see the table, it will find the value as 10. ঠিক আছে?
Yes, sir.
Now, if you choose B, fixing B as green, there is other option for D as green. So this gives you the value as 3. Okay. Now, just before you have asked that question, that whether we should choose the minimum one, the maximum one. If it is a cost, then we have to choose the minimum values. If it is a profit, then we will choose the maximum one. But here
we have chosen cost.
So we will choose the minimum. So for this combination, B as R and R, the minimum we can get only 3. And the combination will be
red.
Right? This is one option to get the minimum one. This is one option to get the minimum. The other option to get the minimum is
green.
Keep B as a green and D as green. Okay.
Okay, sir.
So this message, this is the message, will be sent by D to B.
Only never node.
যার সঙ্গে কমিউনিকেশনটা হচ্ছে
স্যার only never node না?
Of course never node, মানে যে আরটা নিয়ে আমি কনসিডারটা করছি.
Okay.
Now I should tell, listen. I should tell, I told you the values moves from top to bottom and the utilities moves from bottom to top.
Top.
So here the utilities are 3, the minimum. So this particular message will be moving from D to B because this message is being this particular information is being calculated at end D.
Yes.
So D choose the minimum and D tells to B that you can choose red or green, I don't bother. Because if you choose red, I will choose red. If you choose green, I will choose green to get the minimum. So that is the negotiation between the two agents.
Yes, sir.
Okay. So mind it, in the first 2 days class, whatever we discuss about agent multi-agent system, that negotiation, communication, interaction, that we are applying here because this is a distributed approach. And agent is responsible for choosing the color of a particular node. So one agent is running at B, one agent is running at D. So they are negotiating with each other. तुम अगर रेड लोगे तो मैं रेड लूंगा, तुम अगर ग्रीन लोगे तो मैं ग्रीन लूंगा, because that will give you the minimum value.
Yes.
So that will be their negotiation. Just like at the human being. তুমি যদি এটা করো তাহলে আমি এটা করব, তুমি যদি এটা করো তাহলে আমি এটা করব. Just like think of those people who are familiar with the chess. They have their mind set. If you follow this step, I will follow this step. If you follow this step, I will follow this step.
Yes, sir. Yes, sir.
That is this simple strategy. Okay, so here everybody's objective is common. I mean, the overall objective is to total sum should be minimum. So they are not competing with each other, they are cooperating with each other. But for chess, they are competing with each other, they are not cooperating with each other or collaborating with each other. এখানে কিন্তু they are cooperative and collaborative. They are collaborating to get the minimum values of it. সবার অবজেক্টিভটা একই, everyone objective is to get the sum of the, I mean, total value should be minimum, and because we are dealing with the cost.
Sir, if there is no any direct path that like that A and C, then what to do, sir?
I will be coming to that example also.
Okay, okay, sir.
So this message will be sent by D to B. What is the message? The message is this. This contains the interpretation of this message. D will tell the B, you can choose red or you can choose green, anything, I don't bother. তুমি যা নেবে তার রেসপেক্টে আমি চুজ করে নেব to get the minimum. Okay?
Okay, sir.
There could be another possibility that maybe this is 3-3, this may be 1 or 5. So the same message will be sent to B. And B can understand, if I choose the red, the cost will be 1. If I choose the green, the cost will be 5. And accordingly, the remaining computation will be done by B. How I will be coming to that. Okay. Next, choose C. Now we will be choosing the connection from C. So, who are the parents of C or adjacent node of C? B and A. So again, the values will be moving from AB to C, and the utility will be moving from C to AB. Is the idea clear?
Yes, sir.
The values of A and B will be moving from, the values of A and B will be moving from A and B to C. The utility will be calculated at C, and that will be moving from C to AB. Okay. Now, A and B, what can be the possible combination? I have two color. I have two color. What are the possible combination AB can choose? A red, B red, A green, B green, A red, B green, A green, B red. So we will take all the possible combination. And based on that, we will be choosing the values of C. So putting the values of A and B as red, 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 red. If A and B both are red, C can be red. If A and B both are red, C can be green. So you see, keeping A and B as red and red, red and red, C can be either
Red or green.
Red or green. We will be calculating this part later. The value part we will be calculating later, the utilities part. Let us first complete this part of the table. A red, B green. In this combination, what will be the possible combination of C? What can be the choice for C? Red and green again?
Again.
So red, green, C is red. Again, red, green, C is green. The other combination, A is green, B is red. The C can be either red or green. So you see GNR, GNR, C can be. Now A and B both are green, 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 green. What can be the possible combination of C? Either it can be red or green. Okay, now, so these are the values. These are the values. Now we will be calculating the utilities. ভ্যালু আমরা চুজ করলাম উপর থেকে, আবার বলছি ভ্যালু you can check it. Those people who are doing, or at least some people may be doing, so you can check this value. Are you getting it?
Yes, sir.
দেখুন, অসুবিধা হলে আমাকে বলুন, আমি কিন্তু বলতে পারি, মানে বলতে I can discuss it again. Now we are choosing this combination RRG. So BC, R and G, that give you from the table 4. AC, R and G, that gives you 8. So the total value is 12. Okay. Now for all possible combination, for all possible combination of A and B, we will consider the minimum costs for C. For all possible combination of A and B, we will try to find out the minimum cost of C. All possible combination of AB. AB can be both red, AB can be both green, AB can be A red, B green, A green, B red. Okay. So if you see this combination red, 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 the minimum value you will find at 10. So if AB both are red, C can get the minimum value at 10 with red. If red and G green, C will get the minimum value at red with 8. If green and red at A and B, the minimum value C will get at G with 7. Similarly, if both are green, A and B, C will get the minimum value at green 6. So that we have sorted out. So this message will be sent to B. This message will be sent to B. So A will be sending these utility values to B. Values, colored values are coming from top to bottom. The cost values is going from bottom to up. So this will be going from bottom to up. Next, we will be considering the B. Okay. So color value will be coming from top to bottom. Utility value will be going from bottom to up. So if we choose the path AB, take A value. A can be red, A can be green. If A is red, B can be either red or green. If A is red, B can be either red or green. If A is green, B can be either red or green. B can be either red or green. Now, how do you compute the computation? If A and B are red, then AB value take it from the table. The value will be 5. If A and B are red green, the AB value will be. If AB value is green and red, then AB value will be 20, like this way. Now, along with that, while you will be calculating the value of B, you have to calculate the value of C and D, because C and D are connected with B. So with this combination, A and B as red, A and B as red, AB is 5. Take the utility of C, which is the minimum one that we have already calculated. We are calculating C, that is the minimum one. This is C. Similarly, for you take it for D. If AB is red, take the minimum value for D. Sorry. Minimum value for D is 3. So 3. In the same way, for RG, take the value of AB from the table and minimum utilities of C, minimum utilities of D, 19. In this way, you complete the table. So which combination of AB gives you the minimum one? If we choose both A and B as green, that gives you the total utilities as 12. Now, put the values from the top. A green, B green. If A and B green, putting B as green, what values of D that will give you the minimum one? That you will get. D, G. So optimal cost is 12. Select A as green, matches this value to B and C agents. From here, you will get the minimum one, while D is green and C is green. So the result is, all are green. That gives you the minimum value as 12. This is the idea of DCOP algorithm. দেখুন যদি কিছু বুঝতে অসুবিধা হয় আমি বলতে পারি আবার।
So it's okay.
আবার যদি বা যদি মনে হয় যে আবার বলার দরকার আছে আমি আবার বলতে পারি, কোনো অসুবিধা কিছু নেই আমার।
Anyone have any doubt, please ask the questions to sir.
See, little bit, of course, little bit complicated for BTech student, I assume, but somebody can, those who are good in algorithm or in the graph theory, they can think of. The idea is not complex.
Yes, sir. Yes, sir.
I mean, with an example, if you think, that is a very simple example. I mean, simple idea.
If anyone have any doubt, any type of question, please ask.
So you see, if B is green, he can choose either red or green, but you see only the green can give you the minimum value. So that's why we are choosing D as green. That is the idea. If A and B are green, if both A and B are green, C can be red or green, but only the green can give you the minimum value. That's why we are choosing the C as green. Okay.
Any doubt? Please ask the question. Any doubt?
So, as a conclusion, what I told you that we started with the idea that this is an incomplete algorithm. The earlier one was the complete algorithm. The SBB was the complete algorithm, but DCOP is an incomplete algorithm. Okay, no, I think this is DCOP. Yeah, no, DCOP is a complete algorithm, right? I mean, I will be coming to the incomplete algorithm later. DCOP is a complete algorithm. You will get always the optimum result, and in between you cannot get the result. So you have to wait till the termination of the algorithm. So you have to wait till you reach to the end, the complete pruning of the graph. Okay, so these two algorithms, the DCOP and SBB, are the complete algorithm. It will give you always the optimum result. And to get the optimum result, you have to wait till the end. Okay, but in some cases, your number of node, eventually the number of agent is huge. In that case, getting the optimal result will be a time consuming matter. So you may not be able to give that much of time to wait for the optimum result. So in that case, there is an idea of incomplete algorithm where you may have a very large number of agents, you may have a very large number of nodes. You start the algorithm, even you don't need to go to the end of the algorithm, but at the middle of the algorithm, you can expect a result, which you don't expect as an optimal result, but it is a result, and that you can use. So that's why incomplete algorithm cannot give you the guarantee. Incomplete algorithm cannot give you the guarantee of optimality, reaching optimality. But when as complete algorithm, for example, the SBB or DCOP will always give you the optimum result. But to get the optimum result, you have to wait till the termination of the algorithm. Sometimes for large network or large number of agent, this waiting time, this computation time will be huge. So that is an issue. So again, you can think of the as it is I told you, as it is an distributed algorithm. So apart from the runtime complexity, you need to think about the network load, that is message passing complexity, message size, that you need to think. And this is complete algorithm. So under the complete algorithm, both SBB and DCOP come. The solution always finds an optimal solution for both the cases, SBB and DCOP. So if you wait for the termination of the algorithm, it will give you the complete result, the optimal result. I'm not going to now I'll be coming to the incomplete algorithm. So the incomplete algorithm, the name itself says the algorithm is incomplete. You cannot guarantee that it will give you the optimal result. So we'll be discussing synchronous search algorithm, which is called distributed local search. So there are mainly two algorithms. One is DSA, distributed stochastic algorithm. Another is maximum gain message algorithm. Now, take the same example as maximization or maximize utilities. So here the same table is given, xi and xj, utility is AB and BC. If both AB are red, the utility is 5. Both BC are red, the utility is 5. If red-green, AB will give you 5. If AB red-green, the BC will give you 0. Green-red, AB will give you 0. Green-red, BC will is 0. If both are green-green, then AB will give you 8, BC will give you 8. Now, my graph is this, ABC. We have taken a very simple graph, ABC. So there are 3 nodes, A, B, and C. There is an agent on each node. So there is an agent on node A, there is an agent on node B, there is an agent on node C. Agent working at node A is responsible for choosing the color of A. Agent located at B is responsible for choosing the color of B node. Similarly, agent deployed at C is responsible for choosing the color of C node. Now, we have to choose a color for all. I mean, each agent will choose the color for their nodes that will give the maximum utilities. So here we are considering the maximization problem, which will give us the maximum value. Every agent individually decides whether to change its value or not. So each agent will be responsible for choosing the value, whether it will change it or keep it as it is. Decision involves knowing the neighbor's value. That means A can only knows the value of B. B can only knows the value of A and C. C can only knows the value of B. C cannot knows the value of A, or A cannot knows the value of C, because they are not direct adjacent node. So this is the very lucid way it is written, the steps for DSA algorithm. All agents execute the following: randomly choose a value. So it's a kind of heuristic idea. That means the agent can choose any value. They will calculate the cost. They will, in the next iteration, they will choose separate color. Again, they will choose find out the utilities. Again, in the next iteration, they will put different color and find out the utilities. So there is no guarantee that which iteration will give you the maximum value. Even it can fluctuate. Even it can fluctuate the value. While termination is not made, if a new value is assigned, send the new value to neighbor. Collect neighbor's new value, if any. Select and assign the next value based on the assignment rule. So let us take the example. Initially, there is no color for ABC. They can choose any color. And mind it, as we said, this is a distributed algorithms and there are agents for each node. So it may so happen that agents are doing simultaneously or one after one another, because it can be in a synchronous mode or it can be asynchronous mode. So let us assume this is the combination. Earlier no color. In a first iteration, A choose red, B choose green, C choose red. We will find out the utilities. If A choose red, A is connected with B and B choose green, then what will be the value of this arc? That is the utility. A is red, B is green, so the AB value is 5. The value is 5. If B choose green and C choose red, the value of this arc is 0. Sorry, is 0. So if this is the combination of the color red, green, red, the total utilities from this graph is 5 plus 0, right? With this, we will be changing the color of each node and will calculate. For example, we will compare. If A is 5, we are getting this value. That means if we choose A as red, the utility is 5 and the improvement is 0 because it is already red. So there is no question of improvement. Instead of red, if we choose A as green, instead of red, if we choose A as green, so this is green, 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 red. So if it is green, 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 and the value is 8, and this is 0. So 8 plus 0, 8. So instead of red, if we choose it green, the improvement could be 3. If you are interested to know more about it, or if you ask me, I can discuss it once again. The improvement part.
It is okay, I think.
Okay.
To me.
So, okay.
And do you have any other any problem? Please tell sir. All the students or faculty members, please ask the question. Any question, any type of question that may be silly.
Yeah, of course. I don't bother. It will be, there are a lot of things that I can learn from you when I will be discussing. That is a interesting part of teaching. I'm repeating. See, at the beginning, there were no color A, B, C. A can choose any color from red and green. B can choose any color from red and green. C can choose any color from red and green. If we choose this color combination, A as red, B is green, and C is red, then the utility of this arc is 5 because this gives you the 5. If B is green and C is red, then this combination gives you 0. So the total utility of this assignment is 5. Total utility of this assignment is 5. So this is this. What is delta? Delta is the improvement. That means instead of this existing combination, if we choose something else, then what could be the improvement? Here, this is the combination. And if we write again red, so there won't be any improvement here, because A, there was already red in A, and again if we put A as red, then there is no chance of improvement. That's why the improvement value is null. 0. But instead of red, if we could choose A as green, then what will be the utility? This is green. This is green. So green, green 8, and green, red 0. Green, red 0. So 8 plus 0, 8. And the earlier utility 5. So if instead of red, if we choose 8, sorry, instead of red, if we choose green, then we can possibly improve the utility by 3. Similarly, for this, with this combination, there is no chance of changing this color to green because it is already green. So the utility is 5, 5 plus 0, 5, and there is no chance of improvement here. But instead of green, if we choose it to red, then what will be the improvement? If it is red, then red, 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 red. If A red, B red, 5. A red, B red, 5. B red, C red, 5. So 5 plus 5, 10. 10. What could be the improvement? Earlier utility was 5. Now new utility is 10. So the improvement is 10 minus 5. 5.
Okay, sir.
Clear? Similarly for C. Similarly for C, it should be 5. It's wrong. If it is red, then the utility is 5. 5 plus 0. And there is no chance of improvement. But instead of 5, instead of red, if we choose it to green, so red, green, 5, and green, green. Green and green. Red, green is 5, and green, 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 green. So 8. So 8 and 5, 13. It will be 13. This is a wrong actually. 13. So the improvement is 13 minus 5. It should be 8. Yeah, it is already 8. So the idea is, the gist of this iteration is, here instead of choosing red, if we choose green, it can give you the improvement of 3. Instead of green, if we choose it to red, the improvement could be 5. Instead of red, if we choose it to green, the improvement could be 8. So based on this, we will infer, that what will be the next change. Yeah, just we change A. After changing A, again we will do the same iteration. After changing this, again we will be doing the same operation. So this way it will be going continue, and mind it, each iteration will give you a result that may not be optimal result. That is the interesting thing. But each iteration will give you a result. So you see at the end, each iteration, the first iteration gives you this, second iteration gives you this, third iteration gives you this, fourth iteration gives you this. the optimal result with this iteration. Green, 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 green. So utility 8 plus 8, 16. Because we are going for maximization. Now here you see, as we said, it is an incomplete algorithm. In the first iteration, it gives 5. Second iteration, it gives 8. Third iteration, it gives 0. So you see, instead of improvement, it gives you decrement. And on the fourth iteration, it gives you again 16. So there is no guarantees of the solution quality for DS algorithm. That's why it is called as incomplete algorithm. But the beauty of this algorithm, you can take a result of this color combination in any moment of time. You don't need to wait for till the completion of the algorithm. In every iteration, you can expect a result. This is a result. This is a result. This is another result. This is another result. You don't need to wait for the end. But there is no guarantee that this is the optimal result.
Sir, if node number is high, then node number means number of nodes is high. Then it is very time taken, I think, sir. This algorithm time complexity is higher. Sir, so what is the method? This is this disadvantage now. This for this algorithm. Actually, my.
বলো তুমি বলো না আমি বলছি তোমার কোশ্চেন আমি বুঝে গেছি তোমার কোশ্চেনটা কি
So this is the question actually, sir.
Okay.
So I think this is the disadvantage for this algorithm.
Okay. So instead of going for centralized approach, we are going to distributed approach. And we are treating that as many number of nodes are there, that many number of agent will be there. And each agent will be responsible for coloring at its own node. So this agent will work concurrently. So there will be a parallel execution. Nobody is depending on the other.
Okay. So that's why
choosing the color of A is not dependent on choosing the color of B. The agent of A will choose its own color without thinking whether B is choosing or not. Agent of B is choosing its color without thinking whether A and C are choosing or not, because they are not dependent. Very simple example. I have been teaching distributed system for a long in our MTech courses. So when I give the example of distributed system over centralized system, particularly for parallelism, I give a very day-to-day example in my life. So if you allow me, I will give you that example.
Yes, sir. Yes, sir. Sure, sir. Sure, sir.
So the example is in the typically in the winter season, I have 2 kids. One son is a little bit bigger. I mean, he is in now class 7, and my daughter is a very small kid. Now she is in class 2. So in every winter, there is a hurry of sending her to the school through school bus, because she wake up at late and putting the bath, foods and all thing. So it is always late in the school, putting in this school bus. So at the last moment, we started fighting with each other to get her ready. So what I observed, there are some activities in our getting her ready.
Please mute, please, Sahid. Sahid, please mute. Sir, please mute. Sahid Ansari, please mute the mic.
Yes, sir. Yes, sir. Sorry, sir.
Putting the socks and shoes. Putting the socks and shoes of the same leg at the same time cannot be possible. Am I clear?
Yes.
Putting the socks, moja, and shoes of the same leg cannot be possible at the same time. But putting a socks in one leg and putting a shoes in another leg at the same time can be possible if both my wife and me are free to get her ready. Because putting socks in one leg and putting shoes in another leg are two independent tasks. They can be executed concurrently.
Very nice example.
Obviously, you have to have the computation power. That's why I told you, if both my wife and me are free, then only putting a socks in one leg and putting a shoes in another leg can be possible for my daughter. Similarly, maybe I am putting her shoes and socks or maybe the dress. On the other hand, her mother puts her foods in her mouth, because putting the dress and taking the food at the same time can be possible if the computation capacity is there. Your processors are free. So when we say distributed algorithms and we are deploying agent, they can execute concurrently. That is the beauty of distributed system or distributed approach over the centralized approach. They are not dependent on each other. Second thing, if you go for the comparison with the SSB algorithm and this DSA algorithm, or DCOP algorithm with DSA algorithm, for DCOP algorithm and DCOP algorithm and SSB algorithm will always give you the optimum result, but you have to wait till the completion of the algorithm. But for case of DSA algorithm, you don't need to wait for the completion of the algorithm. At any moment of time, at any iteration, you can expect a result. So maybe after the first iteration, you are expecting it, you are looking for a result. You don't want to wait till the completion of the algorithm. So you take the result. Your result will be 5. Maybe after 2 iteration, you want to get the result. You don't want to wait for the last. Take the result at 8. So that is possible for incomplete algorithm. But for complete algorithm, you cannot get that. You have to wait till the completion of the algorithm. So that's why your question is a very valid question in the perspective of complete algorithm and incomplete algorithm. If your number of node is huge, then to complete the algorithm to termination of the algorithm in complete algorithms will be a huge time consuming part.
Yes.
But for incomplete algorithm, even if you have a large number of agent or not large number of node, but you can expect a result even before the completion of the algorithm. You don't need to wait till the completion of the algorithm. তোমাকে ওই পর্যন্ত ওয়েট করারই দরকার নেই, তার আগেই তুমি চাইলে রেজাল্ট পেতে পারো।
Yes, sir. Yes, sir.
Not that won't be an optimal result, but you will get a moderately good result. মানে কম্পারিজনটা এইভাবে হবে, বুঝতে পারলে?
Okay, sir. Okay, sir.
So this is the idea of DSA algorithm, and another is the MGM algorithm. For MGM algorithm is just like it's the modification of DSA algorithm. Here you see in DSA algorithm, in the first iteration we got the value as 5. In the second iteration we got the value of 8. In the third iteration the value decreased drastically, 0. So there is no guarantee that the quality of the result is slowly improving. There is no guarantee, because we are not choosing the maximum one always. We are doing always some kind of arbitrarily, randomly we are choosing the values. But MGM algorithm always choose the it has the highest gain among all neighbors. It choose the highest value among the neighbors. So that's why the same algorithm with the highest value, and change the value to the value that maximizes the gain. It will always give you the, gradually it will give you the best result. So if you see the graph plotting of these two algorithms, the DSA algorithm and MGM algorithm, you see the DSA algorithm is just like a, sometimes it is giving a good result, sometimes it is giving a bad result. But MGM algorithm is always giving you a
improvement result.
Always give you the improvement. It is always improving. That is the interesting part of MGM algorithm. But for if you go for MGM algorithm, the number of message passing will be huge, because each time, each iteration, you need to exchange the messages with your all neighbor to find out the maximum one, and that you choose. Even as you said, you have rightly pointed out that if your number of agents or number of nodes are huge, then the message passing complexity will be huge for MGM algorithm. Because unless you pass the message to the whole network, you cannot choose the maximum value. At DSA algorithm এর ক্ষেত্রে আমরা সেটা করছি না, আমরা arbitrarily করছি, এটা নিলাম আরেকটা নিলাম, just wait, and we are checking it. Okay, so far these are the different algorithms for DCOP solutions. Now there are some example. Energy trading, there are a lot of papers you can find out. The smart grid is one of the biggest research component today, and there are a lot of research papers where the DCOP is used as for smart grid solutions, where each member, I mean each organization is producing the electricity as well as consuming the electricity. For example, we are in NIT Durgapur. There are number of hostels. In the rooftop of the hostels, we put solar panel. So when we have an excess electricity, we can put that solar energy to the grid. We can sell it. But when we need, we can consume it. So one producer is consuming as well as selling it to the market. So in coming days, this will be one of the mandatory for all the government offices, that you have to put the solar panel on rooftop, such that you can use the electricity for your own consumption as well as you can sell the excess electricity to the market. So you need to find out some kind of trade-off, that what amount of electricity you will be producing and what amount of electricity you will be consuming at your own to maximize your profit, to maximize the utilities. So this can be also modeled as a DCOP problem. And if you are interested, you can find the paper in AMAS 2015. This is a paper in AMAS 2015, designing a marketplace for trading and distribution of energy in a smart grid. Okay, not going. There are some more applications on a DCOP problem. Yeah, scheduling problem. So one of my PhD student who completed her PhD in 2018, she used in railway network scheduling and disasters management algorithms. That was her PhD thesis. She used a lot of DCOP algorithms for solving the scheduling problem of railway traffic and disasters management. There is another applications for typically for electronics people, radio frequency allocation problem. Then we have used sensor network, pre-processing of network for accelerating the DCOP algorithm. Adopt is also published in AMAS 2005. Home automation, a multi-agent system approach to scheduling device in smart homes. It is also published in AMAS 2017, eSky 2016. I don't know whether you are familiar or not. This AMAS 2017 or ICHKAI 2016, there is another conference, AAAI. So these are the top level conference in computer science, typically the AI conferences.
Yes, I know.
Okay. So this is AI, AAAI conference. So AAAI conference, I mean, what I say, I don't know. Sometimes people cannot believe, at least in India, that publishing a paper in this type of conference is much harder than publishing a paper in IEEE transaction or some good journal. One of our paper was rejected 8 times. 8 times. In 9th times, the paper was accepted in AAAI 2020, this year. We went to New York. So this year AAAI took place in New York. So these are the typical top level conference in this domain of agent technology, AI, even machine learning, all this thing. So think of starting the PhDs or even MTech student, they can start searching the paper from these top level conferences, what I feel. Okay, then another problem that we discussed in the last class, meeting scheduling problem. So there are some time slot. I am available from 11 to 12, 12 to 1, 1 to 2. You may be available from 1 to 2. One of the colleague may be available in another slot. So how can we schedule the meeting such that there won't be an overlap of meetings of the same persons, and we can start the meeting at the same time. I mean, all can join the meeting at the same time. So meeting scheduling problem can also be modeled in a DCOP problem. Okay, that is also published in 2004 AMAS. Then traffic flow control. Given a set of traffic light in adjacent interaction, how to coordinate them to create green waves. The term green waves is a very fantastic term. In India, you people are familiar with this traffic signal. Maybe in Delhi, Kolkata, Bombay, there's a huge traffic, or even Bangalore, terrific. But one of the country where the traffic is huge, but you don't need to wait much in the traffic. It is in Singapore, where the traffic lights are controlled by an AI system. The idea is, once you move from one traffic light, the time it takes to reach you to the next traffic light, by that time the traffic light will be on. So you don't need to wait. Those traffic lights are controlled in each corner in such a way that your waiting time in the junction will be minimized to optimize the fuel consumption. So all the traffic lights in Singapore are controlled by an AI system. So that is the idea of these green waves. You will always find that there is nothing traffic in the street, but a lot of cars is a huge traffic, but you okay. Then there are some other applications, home assistance, smart homes, device scheduling. Okay. Okay for this today. Bhaskar. Okay.
Okay, sir. Noted.
দেখো কারোর যদি কিছু থাকে বক্তব্য।
Anybody have any question? Any type of questions, please ask. I think all question is done by me, and this is the same questions same questions the students also have, and they have already cleared that.
So this is one area of research where we are working, and tomorrow I will be discussing the multi-agent coalition. So that
Okay,
is
sir.
another one of my PhD students work. Okay.
Okay, sir.
Okay then.
So for today, it is we will finish the webinar, and tomorrow is the last date. So please please prepare a bunch of questions for sir.
Yeah, sure. Yeah.
Because
See, I may not be able to answer those questions. I
yes,
may
sir.
not be
Yes.
able to answer all those questions, but I can learn a lot of things from you. See,
Yes. Yes.
I study operating system in my BTech, my MTech, but actual operating system, the fundamental concept I can learn only when I teach that subject in the BTech curriculum.
That's actually true for us also.
আমি তখন শিখলাম যে হ্যাঁ বেসিক কনসেপ্টটা কি। অথচ ধরো যখন ক্লাসে পরীক্ষা দিয়েছি তখন
Yes.
ভালোই মার্কস পেয়েছি, কিন্তু তার মানে কিন্তু মনে হচ্ছে অনেক কিছুই there are a lot of things that was unknown to me. There was a lot of issues which was hazy for me, but when I started teaching operating system in the curriculum, then it starts going well.
So that's the same thing also. Teaching
Yeah,
learning
it's
process
same thing
is
for every faculty member.
yes, yes. Teaching learning process is both way communication. So please, everyone, prepare. Start. I think all of you get the PPT what sir said sent to me.
Yeah, আমি তো
I have
কালকে
sent
পাঠিয়ে দিয়েছি সব।
yes, sir. Yes, sir. I already sent to the peoples also who have registered that. Then please go through the PPT and please revise all these things and prepare well. And tomorrow one session will be there for question answer session for 15-20 minutes, and that will be good for us. And we will make question and bunch of questions to sir, and sir will, I think, happy to have this
Sure.
questions. So for today it is over, and thank you for joining this thank you sir for this time, and
Thank you so much.
okay, thank you sir.